Hey there, this video will have some additional practice using the method of multiplying times the conjugate to rationalize the denominator. And we're going to try a couple of challenging examples that are really going to help us build our knowledge of this topic. So if we have a square root in the denominator, we want to rationalize the denominator and get those square roots on the bottom to cancel out. The method we can use is multiply by the conjugate, which is taking the first term, keeping it the same, but switching the sign of our second term. And of course, if we multiply by something in the bottom of a fraction, we've got to multiply by that same thing in the numerator so that everything stays balanced. So in our denominator, remember there is a shortcut we can use when we're multiplying if the things that we're multiplying are conjugates. So we just need to multiply the first two terms together and the second two terms together because we know that the terms from the other multiplication will cancel out. Square root of 3 times square root of 3 is just the number 3, and square root of 2 times square root of 2 is the number 2, but a positive times a negative gives us a negative, so we have negative 2. In our numerator, we need to distribute and multiply all four of these terms together because what we're multiplying in the numerator are not conjugates, so we do still need to carry this out like we would any other multiplication with more than one term. So let's get right to our distributing. We've got 3 times the square root of 3, as well as square root of 10 times the square root of 3. We've also got 3 times the square root of negative 2, which will give us minus 3 times the square root of 2. And here, let me clear a little bit more space for us to work. We also need to multiply negative square root of 2 times positive square root of 10. So that gives us minus square root of 10 times square root of 2. Our denominator is just equal to 1 in this case, and anything divided by 1 is itself. So we don't need to write this as a fraction anymore. We can just write this with the terms in our numerator. We've got 3 times the square root of 3 plus, when we multiply together two numbers that are different, but they're both inside of a square root, we keep the square root and multiply those two numbers inside the square root. So square root of 10 times square root of 3 is square root of 30. We've also got minus 3 times the square root of 2, and minus square root of 10 times square root of 2 is the square root of 20. So that's basically our final answer that we get when we rationalize this. But just like we always want to check when we're dealing with fractions, if we can simplify a fraction, we also should check if we're dealing with square roots, if we can simplify a square root by factoring out any perfect square factors. The square root of 3 and square root of 2 are already as simple as they can be, but let's look at these other larger numbers in our square roots. 30 does have some factors, but any of the factors that we try, like 5 times 6, or 10 times 3, or 2 times 15, well, none of those are perfect squares, so we will not be able to simplify the square root of 30 any further. Let's take a look at the square root of 20. There is a factor of 20 that's a perfect square, 4, which is just 2 times 2. So we can separate square root of 20 into square root of 4 times square root of 5. And then we can take the square root of 4, that's just 2. So this is 2 times the square root of 5. So we could write our answer a little bit simpler as 3 root 3 plus root 30 minus 3 root 2 minus 2 times the square root of 5. And we're going to continue on to the next screen, look at another challenge example. To start, we'll multiply the denominator and numerator times the conjugate of the denominator, which means we're keeping the first term the same, but switching the sign of this second term, so that becomes a negative square root of 6. And when we distribute and multiply a conjugate times itself, we can use the shortcut that we're just going to have to multiply the first two terms together and the second two terms together. Negative 3 times negative 3 gives us positive 9. Square root of 6 times square root of 6 is 6, but that is a negative because we have a positive times a negative. In our numerator, though, that is where we're going to need to distribute everything the long way and multiply this all out. So we have 3 times negative 3. We also have negative square root of 5 times negative 3. And then if we multiply the terms from our numerator here, multiply the terms from our numerator here times negative square root of 6, we have 3 times negative square root of 6, and negative square root of 5 times negative square root of 6. When we're multiplying square roots together, if we have two different numbers in our square roots, we'll multiply those together underneath the square root. So root 5 times root 6 is root 30. And so is negative root 5 times negative root 6, because a negative times a negative equals a positive. So in our numerator, we've got 3 times negative 3 is negative 9. Negative 3 times negative root 5 becomes positive 3 root 5. Negative 3 times square root of 6, we'll just leave that as negative 3 root 6. And we saw before that negative square root 5 times negative square root 6 gives us positive square root 30. And all of this is over 3. So let's see if there is anything we can simplify in this case. Since we have a 3 in the denominator of our fraction, we want to check each of these terms in our numerator. And these first 3 terms are divisible by 3, but we cannot divide the square root of 30 by 3 because we can't divide something that's inside a radical by an integer, a whole number. So we can't divide by anything. And we also saw before that we cannot simplify the square root of 30. So there's nothing else that we can do in that problem, and that would be our final answer.